This is another very useful shortcut. You have to find the value of this angle here, and these are your answer choices. One concept that I would explain is, see, if there is one line, you have to go from point A to point B. See, the higher route you take, the longer route you take from A to B, the higher you go, the longer you go, this angle will keep getting smaller, and these angles will keep getting bigger, you know. So see, if I took a shorter route, here this angle is bigger, but relatively these angles are smaller. If I do not make an angle at all, if I just take the straight line, see, this angle is the highest possible angle, 180 degrees. And the vertical angle, these angles have become zero, you know. So remember this small thing, it will help you a lot. So I know it says that DEC is an equilateral triangle. So this has to be 60 degrees. Now come to think of it, from D to C, I am here, this is lying lower. This is a shorter route, so F has to be a bigger number than 60. So these values can just go. It has to be greater than 60. These are the two contenders. And now come to think of it, 80 is such an absurd number. Talking about square, the angles are 90. Talking about equilateral triangle, the angles are 60. Talking about a diagonal here, the angle is 45. So 90, 60, 45, there is no way you can get to an absurd number like 80, you know. So out of these numbers, 75, see, makes some sense, you know. A 75 can be reached at, you know, through some addition, subtraction and all, you know. Remember that triangle, whenever a triangle is involved, a number like 180 is always somewhere around the corner. So look at these numbers, a number like 80 cannot be reached, you know. This has to be also eliminated. The right answer is 75. Of course, practically if you were to solve it, it's an easy question. 45 here, 60 here, and therefore 75 here. But see, the 75 has been reached by these values only, 180 minus 60 minus 45. You know, so in case this doesn't strike, you can always, you know, apply this common sense. You know, when I was taking my tests, I would very often apply these shortcuts before I would actually go about solving the questions, you know, if the options just look completely wayward. Take one more example. This is a square, this is an equilateral triangle. The question is asking this angle. And these are the answer choices. Now what do I do? What I do is, again, similar stuff. I just eyeball. I would need to make sure that everything is to the scale. Yes, it is a square. And I would just need to make sure that, yes, this is also looking equal. So it is a figure drawn to scale. And then I just eyeball that, yeah, number like 45 is too big. See, entire thing is 60. So 30 would mean half of this. This is definitely not half of this. This is less than half. So 30 can also go. Now see, I have three close choices. But once again, the same concept. I'm dealing with a square, so I have 90. I'm dealing with an equilateral triangle, so I have 60. Uh, when a triangle is around the corner, something like 180 is always there. So think a number like 10 or 20 is awkward, you know, whatever happens, whatever number I'm going to get has to be, these are all multiples of 3s. You can add and all, you know, you never divide. So whatever result I'm going to get has to be a multiple of 3. Okay, 10 and 20 are not a multiple of 3. The only value that remains is 15 degrees. That has to be the right answer, you know. Doing it mathematically, of course. This is 60. This is 90, this is 60. So 90 and 60, 150, and these two sides are equal. So these two angles have to be equal. 150 is taken from here. So 30 remain, each of them have to be 15 each. That's a mathematical way, but yeah, of course, under exam pressure, sometimes this may not click. So this is how you reach to the right answer very quickly. Let's take one more example. This is quite a difficult question. You have to find the area of this part, and this is a rectangle. It's given that figure is not drawn to the scale. Even by eyeballing, I can sense that it is not drawn to scale. This is 3 and this is more than double this value. See, this eyeballing and approximation is going to work only when you have the figure drawn to scale. So the first thing that I'm going to do here, if I am to solve it by approximation, is to have a figure drawn to scale. If this much is 3, 4 should be like 30%, 33% bigger than this. So this now looks like a 3 by 4 rectangle. So I first draw this. If I'm drawing it on my scratch paper, I would have proper boxes, and also it would be easier to draw it uh, on paper to the scale. I'm drawing it on screen, so it is just a bit okay, difficult. So I know this is 3, this is 4, so this becomes 5, and EF is 2. So 2 should be like less than half of this, just a bit less than half of this. So something like this. This much should be 2. So now I have a figure which is drawn to scale. You know, I have to find out this value. How do I do it? By approximation. I know the entire rectangle is 12. So this rectangle, this triangle has to be half. Area of triangle ADB, half triangle is 6. And I need to figure out that what percentage is this area out of the entire area. So for this, what I suggest is you just try to break this entire thing into smaller symmetrical things. So I draw something like this. So try to have smaller areas of of equal value. So now see this, these two triangles become almost equal. Uh, this becomes almost equal. So these two and this would become almost as equal in area. So I have 1, 2, 3, 4, and roughly 5, a bit more than 5, something like this. This is narrow, so probably this entire thing can be counted as 1. So I have 5 areas of this size, this triangle, this size, and this required shaded part is taking 2 out of roughly 2 out of 5 parts. The entire thing was 6, so 2 out of 5 should be roughly 40% of this. So that is 2.4. That's the right answer. So this was a very difficult question, but yes, this eyeballing may just help. And some of the answer choices by eyeballing you can figure out do not make any sense at all. You know, it has to be a value approximately 40% or so of the entire this triangle. And again, you can look at this. You have a 3 here, you have a 4 here, and of course, while finding out the areas, you have a 2 here. While finding out the areas, somewhere these numbers are going to be multiplied, you know. And the other choice that makes some sense approximation wise is 2. So from a 3, 4 and 2, by multiplying, it's virtually impossible to get to a 2. My result once again has to have you know, a 3 in it somewhere, you know. So this has a 3 in it. If I had a number like 2.2, this would be even closer. But think, for getting a 2.2, the prime number I need is 11. Where do I get 11 out of these 3, 4 and 2's written here? Suppose the number was 2.3 also there. For 2.3, the prime number I need is 23. I would never get a 23 out of these values given here. So even if there were some answer choices closer to 2.4, I know that through these numbers I don't get to the relevant prime number for getting such values, you know. So 2.4 has to be the right answer. Okay, some more. So this is another very difficult question here. It's given that these are two circles. These are the centers, and when you join these points, they all become tangents. This is what is given. If you try solving it mathematically, you may be able to solve it, you may not be able to solve it, but by approximation, you'll at least be able to make an educated guess. Please remember, I'm not recommending approximation over conventional methods. I am suggesting this as a smart tool for saving time sometimes, and of course, for making educated guesses when you are not able to solve the question through the conventional means. So let's look at this. The radius is 10. That means one circle has an area of pi r square, which would be pi into 10 square, 100 pi. The answer choices are these. 100 pi is the area of the entire circle, and come to think of it, how much is this as a part of the entire circle here? Roughly 20% or so. This is 1/5 of a circle, something. So, or maybe even less, 15%, 20%, something like this. So my answer has to be something like 15 pi to, on a higher side, say 25 pi. It's definitely not 25%, less than that. So 20 pi. 15 pi would be roughly 50, and 20 pi would be roughly 70. So my answer has to be between, say, 50 and 70. And now let's look at the answer choices. 50 to 70, 20 can go. 50 pi would be like, this is like 160 plus. This can go. 50 pi minus 100 is like, this is around 50, 60. This is in the range. This can stay. 100 pi minus 100, this would be above 200. This can also go. So we have three options eliminated. We are between 50 and 50 pi minus 100. Only two options make some sense. See, the values are very, very close. Both the values are approximately 50. But then come to think of it, this is talking about area, and there is a curve involved. There's a curve involved. It is practically not possible to have an answer free of a pi in it. See, the answer that I have for the entire circle is 100 pi. That's the value of the area of the entire circle. This is a curved thing involved. Whenever a curved thing is involved, there, whether it's area or the perimeter, a pi has to come. So although the values are very similar, very close, I would go with an answer choice that has a pi in it. This is the right answer choice. All right, so with that, we have covered quite a few concepts. There's no end to these techniques. I've tried to cover the ones which are the most helpful. Uh, Again, please don't make this the main course of your preparation. This is all only for helping you with that extra edge on the D-Day. Hope this helps. For any queries, write to us. We'll be happy to hear from you. Thanks for watching.